So first let us see that. So initially I'm going to take a small class. So remember that our Java is object oriented programming language. As you know that object uh, object oriented programming language is nothing but what? Everything is going to be dependent upon a object. So that if you are going to create any object, compulsory, compulsory for that object there should be some class. If you are going to create an object, compulsory there should be some class for that. So let us take class A, class A, and here I am going to take a small example, that is int A equal to 10, and I am going to take B equal to 20, for example. Now, generally in a class, if you consider any class, it is going to contain mainly two things. One is data, another one is methods. So, what is the main purpose of data? The main purpose of data is, so if you want to perform any task, for example, so I'm going to consider a class. Class is nothing but combination of generally methods and data. So what is a method? Method is nothing but a, observe, method is nothing but an action. That means a task. I can consider it as an action or a task. So if you want to perform any action, that is, I'm going to take a small example. If you want to perform a method called as add method, so what we require to perform this add, I require some data. For example, 10 comma 20. So the meaning is what here? This is a task and this is a data. If you want to perform any task, compulsory we require what? Data. So let us consider you are having only, you know how to perform the operation or a method, but you are not having the data. Then can we do any action? Let us consider. I am asking you to perform addition. I have not given any data to you. Then can you perform that addition? No, it is not possible. Second case, I am giving you only the data and I am not going to tell you any task to perform. Will we get any result? No. That means we require both methods and data together, so that finally we are going to get some output. So that in our class, generally we are going to take data and methods. So generally data is going to be stored inside what? Variables in general. So here I am going to take, for example, add I am going to take, and just I want to show you how to perform addition of two numbers here. So int a plus b, sorry, int c equal to a plus b I am going to take, and my program is completed. Now observe carefully here. If I am going to consider this class A, I am having what? Two variables A and B, and inside this method I am going to take one variable C. Now to access the members of this class, that means what are the members of this class? Members of this class is nothing but data, and these two are data members. I can consider this one as a method. This is also a member of a class. Now to access these members from outside of the class, for example, I am going to take one more class called as class B. So generally you know that your program is going to start from public static void main in Java. So if you want to write any type of operations, write them separately inside another class, and it is recommended to write one more class. For example, I'm going to take this class as, for example, I'm going to take the name of this class as main. I'm going to take it as main for suppose. So because I'm going to write main function inside this. So let us take it. So public, already you know the syntax, public static void main, and as you know the syntax, as a parameter I have to take string array args. Okay, string args, for example, I'm going to take like this. Now observe carefully in my program. I want to perform addition of two numbers so that I have taken one class. For example, class name is addition class, and inside that addition class, I am going to take a method called as add. So now if you want to execute addition operation or add operation, where it is present inside a addition class. So whom do you require here? I require object of type addition. So how to create an object of any class? I have to write the class name. I'm going to write a class name here. Next, I have to write some reference and we have to use a new keyword and I'm going to write again a class name and we are going to close it with parenthesis. So later I will explain what is the use of this one. Later I will explain. Now just I am going to call what? X dot add. X dot add. So what happens now? Control. So X belongs to whom? Addition class. So whenever I'm going to call X dot add, automatically the controls already internally. Whenever you are going to create an object, some memory will be created for that object, and it is referred by what? X. You can see here. This is a reference variable, and inside this, what we are going to have? All the members, all the instance members of a class. So here we are going to have A equal to 10 and B equal to 20 and we are going to have add method. These three are available for your X. So now I am going to call what? X dot add. So we are going to execute this method and here what I am going to take? I am going to perform addition of two numbers. After performing addition of two numbers, the value is stored in where? C. If you want to print it out, just write down print statement system.out.println, just print C. That's it, completed. Okay. So this is about the concept of how to write a basic small program. Okay, right. So if you are having any doubt regarding to this, please send me through a chat box. So as I have started from basic, it will be very easy to understand how to write a basic program or later on we are going for different concepts which will be very easy as we are going in sequence. Okay. So this is a basic program, right? To make you clear, just to understand because compulsory if you are going for your examination for every question you have to write the program so that compulsory you should know how to write a program. Okay, right. So that I have shown you that. So once again I'm repeating, if you are having a small logic, it is recommended to go for what? A single class, and inside that single class, please take void main public static void main string args, and inside that write the logic. Otherwise, if you want to write this logic inside another class, it's your wish, as we have seen before. Okay, right. Now next concept. So this is how to write a basic program. In your basic program, what we have seen. So to create a class, I am going to take a keyword called as class. Class is a keyword. And beside class, if you are going to write anything, it will be treated as class name. And flower bracket open, flower bracket close. So this is the structure of your class. So inside this, what we are going to have in general, data and methods in general. So later we can see constructors on all remaining things, but in general we are having what? Data and methods. Okay. So this is about how to write a Java program. So now let us see the basic things about your Java program. The basic is nothing but, so if you want to write any program, initially we require what? Data, and later we require what? Methods. So before going to create a data, we should know what are the different types of data types available in our Java. So I'm going to tell you clearly, please observe carefully. So now I am talking about 1 minute. Now I'm talking about the concept of data types. So what is meant by a data type? So data type in our Java, Data type in our Java is nothing but what? It is going to represent the type of the data. Generally, in our Java, we are having eight primitive. Sorry, first I will discuss about this one. There are sorry, there are eight primitive data types are there. Eight primitive data types. Primitive data types. So generally, there are two types of data types. One is primitive, another one is non-primitive. Observe that. So now here I want to demonstrate only about primitive data types. Okay. So how many primitive data types are there? Eight primitive data types are there. So here, if you consider any other programming language like C language or C++, there in the data types we can't say exact number of data types because they will say like there is int, there is signed int, there is unsigned int, there is short int, there is long int, there is unsigned long int, unsigned short int, signed short int, and so on. That means what it leads to confusion. Many different type of uh, keywords are added to the primitive data types there, short int, long int, in that way. But here we are having fixed that those are eight primitive data types are there. Those are first one. I'm going to categorize these. Mainly these are categorized into numerical, next one characters, character types, and finally Boolean types. Mainly your data are dividing into these three types. Again, this numerical data type is going to be divided into two. First one is, if you see this one, integral data or integral data types. Next one, floating point data types. Floating point data types. Coming to this character, nothing, no other characterization is there. Next, no other classification is there, and same for Boolean also. Coming to this integral, under this integral, we are having four data types. First one is byte, second one is short, and third one is int, and last one is long. Next, coming to your floating point types, there are mainly two types. One is there are two data types for this floating point numbers. One is float, another one is double. And for this character, there is only one type, that is char. And for our Boolean data type, we are having there is only one data type, that is what? Boolean. So total, I am having eight data types. Among them, four integral data types are there, and two floating point data types are there, and one is char, another one is Boolean. So this is about eight primitive data types. So now I am going to explain in detail about every data type here. So first I will discuss about numerical data type, that is nothing but integral data types. Next I will go for floating point types. Later I will show you about char, and finally I will show you about Boolean. So these are a basic concepts which are very important because as you know that this may be given for 5 marks or 8 marks or 10 marks question. So it is recommended to see the basics. Reason basics will be very easy when compared to the next high level concepts. So that I will explain in detail about these data types. Now, first I will explain about integral data types. So just observe, and if you observe that I have written some order here, I am going to tell you in the same order. Reason also I will tell you here. Now see, I am going to take first one, integral data types. So whatever I am telling, listen those words and also observe what I am going to write here. Okay, integral data types. So first, before going to see in detail about these, I am going to tell you about the sizes and ranges of these data types. First one is byte. Again, I am maintaining the same order. Observe. Byte, short, int, and long. The same order it is recommended to maintain. Reason, observe here. Byte. Already you know, no need of by harding these sizes, because you know that Byte means what? How many bytes? Byte means only one byte. Okay. Next, coming to short. If you see short, already I have written in order. So that how we have to remember that means just double this size. If you double this size, we are going to get what? 2 bytes. In the same way, int double this short, we are going to get what? 4 bytes. In the same way, if you are going for long, double int, we are going to get 8 bytes. So the meaning of this one is what? So it is recommended to go in the same order so that no need of remembering these sizes. Now, okay, these are the sizes. Now I want to talk about ranges. This is about sizes. So before going to see the sizes, here also no need of by harding anything. Just I want to make you, before going to this, I want to give you a small example. That is, let us consider internally the data is going to be represented in the form of bits. Okay, I think if you see the subject called as the digital logic design, that is nothing but DLD. There, everything we have seen only zeros and ones. In the same way, here also the data is going to be stored in the form of zeros and ones only. That is, let us take A and B. I'm going to talk about only 2 bits. If you talk about, okay, before that I will talk only about 1 bit. If you are talking about 1 bit, inside that 1 bit, inside this 1 bit location, what can I store? I can store either 0 or 1. Okay, that is what, if I am having only one location, I can store how many? Two values. How many values? Two values. Next, in the same way, now how many bit locations are there? Two locations are there. So how many different values can be stored? First one is here 0, here 0. Next one 0, 1. Next one 1, 0. And finally 1, 1. Total how many values we have? Four values. If I take 3 bits, this is 2 bits and this is 1 bit. Now if I am going to talk about the concept of 3 bits. So 3 bits, I'm going to have 8 different values. In the same way, 4 bits, I'm going to have 16. In the same way, 5 bits, I'm going to have total number of are 32 bits and so on. Sir, how we are getting these values? If you see 1 bit, how many values I can store? Two values. If I'm talking about 2 bits, we can store how many? I can store four. That is nothing but 2 power 1. This is nothing but water. 2 power 1. This is nothing but 2 power 2. This is nothing but what? 2 power 3. This is nothing but 2 power 4. This is nothing but what? 2 power 5 and so on. If you are going to take n number of bits, you are going to get, for example, this is n here. You are going to get the number of values as 2 power n. So now, after this one, you may get some clarity how the values are going to be stored. Now observe here, I am taking, see, now here what I am going to do is, just I will say you the ranges. So the ranges are, so here 1 byte means 8 bits, okay, and 2 bytes means 16 bits, and last 4 bytes means 32 bits, okay. Next, coming to 8 bytes means 64 bits. So already you know that if I am talking about any number, for that we are having positive and negative. So that here, what is the range of? These are sizes. One is in bytes, another one is in what? Bits, bytes and bits. Now, if you know these bits, it is easy to find out the range. So first I will talk to you about this one. 2 power 8, which is nothing but 256, which is nothing but what? 256. That means per byte I can store 256 different values. Sir, what are those 256 different values? Means already I told you that we will have both negative and positive numbers. So minus 128 2 plus 127. So this is the range of your byte. Sir, how we got this? Already I make it as what? 2 power 8 equal to 256. So in this 256 different type of values, I will get what? half negative numbers, half positive numbers. So minus 128 to 0, sorry, minus 128 to minus 1. Total 128 negative numbers are there. From 0 to 127, 128 positive numbers are there. Instead of writing in this way, just I can write what? Minus 2 power 7 minus 2 power 7 2 plus 2 power 7 minus 1. So decrease one value here just. So why to decrease that one I will explain you later. And the same way now. Coming to this short, I am not going to write all this again. Just I am going to write minus 2 power 15 2 plus 2 power 15 minus 1. In the same way this one minus 2 power 31 2 plus 2 power 31 minus 1. Finally this one minus 2 power 63 2 plus 2 power 63 minus 1. So these are the ranges of, so this is nothing but minus 1, okay. So this is minus 1. In the same way, this one is also minus 1, and here also it is minus 1, okay. Right. So these are the sizes and ranges of your data types. So if you go in detail about this, what are the values? Minus 32,768 to, that means what? Here I am going already initially I am going to show you in the range of in the power range. But now here I am going to write the values. So minus 32,767. In the same, if you take this one, you will get a larger values like 2147. Don't by heart these values. 483648. 2. No need of remembering another one. Just write down all the same values and last place 7. Okay. So if you write this long value, it will be very huge. So I'm not going to write this value here. So this is about your integral data types. Okay. All right. Next one. So I want to explain before going to float. I want to explain in detail when to go for byte, when to go for short, when to go for int, and when to go for long. So if my value is very smaller, for example, it is in between the range of minus 128 to plus 127. It is recommended to go for the concept of byte. Okay, because my value is very small. If your size is going to increase, it is recommended to go for what? Short. In the same way, if you are somewhat large, it is recommended to go for int. If your number is larger than int, it is recommended to go for long. So by default, among all these, it can store what? Numerical values, integral values. But if I write any number here, now I am going to write 25. Is it byte value by default or short or int or long? This is nothing but by default, if you write any integral number, it is by default what? Int. And next coming to, if I am going to write any variable here, int x equal to, if I'm not going to write any value, for example, int x semicolon I have written, in the same way byte b semicolon and so on, short s semicolon, long s semicolon, what will be the value of this x and b? By default, for all integral values, the default value is what? 0. Default value of all integral types is what? 0. Right. This is about your integral data types. Now we are going to next concept, that is floating point types. So here is there any doubt in this integral concept? Right. Now I'm going to next concept. Now observe here, I am talking about floating point numbers. So you know that floating point types are of two types. One is float data type and second one is double data type. Okay. So as you know that you may not have a clear clarity about these two. So first I will tell you the ranges. So sorry, not minus. It is, I want to tell you the size. It is 4 bytes. And if you are going to consider the double, double to this float, which is nothing but 8 bytes. So these are nothing but our ranges, sorry, sizes. These are sizes. And now, if you want to get the range, generally, it is we cannot remember these type of ranges, but I am having a small idea about this. Just it is nothing but a 4.9 e power 324, I think, to some 1.8 e plus 308. This is one point. So please don't remember these ranges because no one will ask you about these ranges. In the same way, for double also, we are having some ranges. Okay. Now, sir, we know that there are two types. But what I want to know is what is the difference between these two, sir? Generally, if I am going to write a number, see, observe here, 5 point, I am going to write some number, 25.32, for example. You may get some doubt that, this is a floating point number because there is a decimal point in between the digits. This is what a floating point number. Floating point number. So, as it is a floating point number, what should is it a float or double? By default, if you are going to write any floating point number, it is by default what a double. That is, if I'm going to write some x equal to 25.32, this is which type? The value is double type. So compulsory I have to store inside a double. Sir, I want to represent float. How to represent a float number? Observe now. Float y equal to, I am writing what? If I write from 35.83, for example. Now, if I'm going to write any floating point number, by default, it is what? Double. I cannot store double value, which is a larger value to float. I cannot store 8 bytes into 4 bytes. Then what I have to do? Just I have to place F. What is that? F after the number. So now this double value becomes what? Float. So now it becomes float, and here y is also a float, so we can store that. So this is about the default value, and if we want to create a double, how we have to store, and if we want to create a float, how we have to convert double to float. Now see here, differences I want to tell you. The the differences between float and double, mainly two differences are there. So here the size of this one is 4 bytes and the size of this one is 8 bytes. First basic difference is this one. Next, coming to a second one, if you are going to talk about this one, float is going to act as it is representation single precision. So if you read the concept of digital logic design, there you can see this point. So this is nothing but what? Your floating point data, that is float data type, specifies what? A single precision value, which uses 32 bit. And coming to your double, it is nothing but a double precision. For both, we are having the standards which are given by IEEE. For single precision, I am going to have a standard IEEE 754. For double also, I am having a IEEE 754 standards, which are given by IEEE. Now, one more important point here, if you observe. So here we have seen three differences and one more difference. Sir, after a number, after a decimal point, if I want only few decimals, for example, I want only few digits, then it is recommended to go for float. How many values are? 8 decimal places. If you want after decimal point, if you want 8 places, it is recommended to go for float. If you want nearly 15 to 16 or 16, let us take. If you want to take 16 places after decimal point, it is recommended to go for what? Double. So mainly this is the difference between float and double. So based on your requirement, you can go for float or it is double. So this is about floating point numbers. Okay, any doubt in this? Right. Now, let us see about a char data type. So this is a only single data type we are having under our characters. So, but many things we have to know about this char. So the size of this one is 2 bytes. Size is what? 2 bytes. And that means what? 2 bytes is nothing but what? 16 bits. So first thing you have to understand that, first thing you have to understand that till now we have seen numerical data types. Those are what? First one is byte, next one is short, next one is int, next one is what? Long, we have seen long, and next one is after long, we have seen float. After that, we are having double. All these are considered as numerical data types. So if we are talking about numbers, there will be positive and negative. But now I am talking about what? Character data type. The data type name is what? Char. So here there will be no negative numbers. So the range is here 0 to 65,536. That sorry, 0 to 35,535, 65,535. That is total values are 65,536 total characters. Sir, you are talking about characters, and again you are writing here numbers only. Don't think like that. Let us see why I have written numbers here. So your char data type follows Unicode character set. It is using what? Unicode character set. So as you know, as key in your C language, here we are using Unicode. Sir, what is this Unicode? For every character starting from 0, 0, 1, 2, 3, and so on up to, for example, in between I will take 97 and so on. 65,535. Your Unicode contains what? 0 to 65,535. For every Unicode, that is for every Unicode, we are going to have corresponding character. So here, as we know regularly about 97, for 97 we are having a character called as A. In the same way, if we talk about Unicode 65, we are going to have capital A. 66, it is nothing but what? Capital B, and so on. So now you can understand there are total of 65,536 characters which are having Unicode of 0 to 65,535. So now observe carefully here. You may get one doubt that, sir, why these many characters are there? As we know that alphabets, if we consider capital letters A to Z, total 26 characters are there. If you consider lowercase, for example, again here also how many are there? 26 are there. If you consider numerical 0 to 9, here we are having how many? 10. And let us take some special characters. As we know, for example, I will take up to 50. Range total values are 50. So if I count all these also, for example, suppose 5, 6, 7, 8, 9, 10, 11. So total I am getting what? Only 112 characters only. Why and from where we are going to get all these 65,536? That is in our Java. We are following Unicode character set in these alphabets of all languages. Remember that? Alphabets of all languages in the world. Languages in the world. So which are registered in the world or which can be written, which is having some uh, which we can write. Okay, those type of alphabets are present in our Java. For example, so English is there, as you know that, and we are going to have Telugu in our character set. We can have Hindi, we can have Urdu, we can have Tamil, we can have Malayalam, we can have Japanese, we can have Chinese, we can have so on, Arabic, and so on. There are many language alphabets are there, so that these many characters are available in maximum. These many characters are available in your Java. Okay, in your character in Java. So now how to represent a character, sir? So if you are going to write char, some x here. So x is which variable? Char variable. Inside that I have to store one character. So to represent a character, generally I am going to use what? Single quotes. What is that? Single quotes. So now tell me what value that is present in x. A is a value that is present in x. So I am going to tell you in detail and very uh, in order so that you have to understand and it will be easy to write a program. Okay. So this is about char data type. And finally, we are going to have the concept of Boolean. So as you know that Boolean data type generally it is not having any that is what you can we will not have any size for this one. Reason it is not having any range, just it is going to have only two values to store. That is one is true and second one is false. Okay, don't talk about any size here. If you want to talk size in depth, it will be dependent on Java virtual machine. That is, here, if you are going to create any Boolean type, Boolean, for example, D, I am going to write. Here, which values has to be written? Either true or we can write what? False. So this is about Boolean. Here I can write what? True or false. And you have to observe one thing here. So these true or false should be in lowercase only. Very important. In lowercase only. Sir, generally we will not use this. You may think that generally we will not use this, but if you write any conditional statement, it returns what true or false. So here I am going to write true and okay, okay. Now see, sorry. So I'm talking about what? I am talking about literals now. Till now we have seen about data types. Now we are talking about literals. Now see, this is a data type. I have created a variable. Now the concept is which type of values has to be placed here. That means in the place of this question mark, which values has to be placed. So I am going to tell you that four different number types, number systems I can place here. First one is binary. First one is what? Binary. Second one is, as you know, that octal. Third one is decimal. Okay. Next one, hexadecimal. Hexadecimal. Right. So these are the four types of number systems you can place for this one. Same logic will be applied for your byte, short, and long also. Just I will explain only about this scheme. Now see here, sir, how to represent binary. Please place 0b, 0b in front of the number. If you place 0b in front of a number, it indicates it is a binary. This is what? Binary. So just binary means what? I have to write only zeros and ones. If I write this one, what is the x value? So by default, x stores what? A decimal. So the value is 5. Next one. If you want to represent octal values, you have to represent, 1 minute, we have to write zero in front of a number. As if you are going to write zero in front of a number, it indicates it as an octal. If it is octal, only we have to write 0 to 7 values, so that it has to contain only 0 to 7 values. So it is 7, it is 6, it is 5, there is no problem. Now, what value is going to be stored here? So 765 is an octal number. It will convert the 765 to decimal and stores in X. Decimal of decimal of 765 will be stored in X. Okay, right. Now, next, to represent decimal, no need of representing anything, directly write the value. So in this decimal, I can do what? I can have, in decimal, I can have how many values? 0 to 9, anything I can write. Now, so this is semicolon. Next, last one, hexadecimal. If you want to write hexadecimal, I can use 0x, and we can place 0 to 9 and A to F. So I can write some A here, 3, 2, some C and semicolon. Okay, this is hexadecimal. So this is about literals. Okay, next, coming to floating point literals. Floating point letters I'm talking about. So by default, every value is what? Double. So here we can write 10.5, for example. So it is double. Now, if you want to represent a float, we have to write, for example, 11.5, and we have, this is what? By default, observe now, this is 11.5. If you are going to write any decimal points in between number, by default, it is going to be considered as double. So to make it as float, I have to write what? F after the number. So this is about floating point literals. In the same way, you know that for char data types, I can have what? Char x, as for example, and in single quotes, I have to write a character. For boolean, we have to take only two values. One is for boolean, I can take two values. One is true, another one is what? False. So this is about the concept of literals. So we have completed the concept of data types, and also we have seen the concept of literals. Next, let us see the concept of, see, basics are completed about the data types. Later, let us go to the concept of variables. Variables. So variables generally, uh, first I want to tell you what is a variable. Sorry. Before going to this variable, I want to demonstrate about the concept of identifiers. So identifiers. So identifier rules are nothing but, for example, so if you want to write any name in Java is called as what? Identifier. For example, class A. So this A is what? Name of the class. And next, if I'm going to take any, for example, int x. Now x is what? X is a variable name. For example, x equal to 10 I'm going to take. So here x is what? Name of the variable. So here any name in Java is what? Any name in Java is an identifier, because these are used to identify something in Java. Here A is used to identify a class, X is used to identify a variable. So what are the rules? So if you want to write any identifier, it should contain only lowercase a to z, and next uppercase a to z, and next only digit 0 to 9 and underscore and dollar. Only these symbols has to be used if you want to write any identifier in Java. Next one, digit should not be, here listen these rules. Digit should not be, that is number should not be a first character, should not be a first character of who? Identifier, first character of identifier. So this is second rule. Next one, we can we can have, observe this, we can have any length. That means if you want to write a larger name, larger identifier, there is no problem, we can write it any length. Next one, keywords are not allowed. Keywords are not allowed. That means what? Inbuilt, we are having some keywords like if, else, try. cat, and so on. So those are not allowed to write as an identifiers. And next one, if we consider this one, it is our identifiers are case sensitive. That means what? For example, int a equal to 20. I am taking a value as 20. And if I write int, again I am going to write what capital A. This is what capital A equal to 30. If I ask you, for example, a value, you are going to tell me what? 20 or 30, because as we are humans, we are not going to consider cases. But according to your Java, this is lowercase a, this is uppercase a. It is going to consider cases. That means it will differentiate this a and this a. It knows that it is a lowercase, this is uppercase. So our Java is case sensitive. Your identifier is also case sensitive. Finally, class names, class and interface names can be taken as identifiers, but not recommended. But not recommended, because it may lead to confusion. Okay. So these are the rules of what? Identifiers. This is also a basic concept. Now let us see the concept of variable. Okay. So what is a variable? It is nothing but a small memory unit. That is what? A memory unit where we are going to store a basic data. So previously we have seen some example, that is int x equal to 10 or int y equal to 20. We have seen that is nothing but a variable. So if you want to speak officially, the variable is nothing but a basic unit of storage in Java program. So how it has to be defined? So to define any variable, it should be the combination of, already we have completed the data types. So it is combination of data type. The type is nothing but data type. And here we have to write what? A identifier, or we can say it as a name of a variable. So identifier, and here we can write values or value. So this is in this way. So mainly this is what? Type, and we have to write identifier. After that we can write what? Value. This optional value can be optional. That means what? I can write, for see this one, I can write int x. The concept we are discussing is variables. Okay, variables, right? So here if I write int x, there is no problem. Next, int, I am going to write int y equal to 30. Here, this value is optional. Without writing the value also, we can declare a variable. So int x semicolon is nothing but a declaration of a variable. What is that? Declaration of a variable. Coming to next concept, next one. Second one is what? I am declaring a variable called as y, and I am going to initialize the value also. Now, one more point I want to tell you, that in the same line, I can declare any number of variables which are of same type. Now if I declare in this way, what you are going to get? Three variables of which type? Int type. In the same way, if I want to initialize the values in the same line, I can initialize in this way: x equal to 10, y equal to 20, and for example, z equal to 30. This is what initializing multiple variables in the same line. Instead of writing like this, we can also write int x equal to 10, for example, and I'm going to place semicolon here. Next, I'm going to write int y equal to 20, for suppose, and I'm going to write int z equal to 30. So instead of writing one line, we can also write these three lines. So among these two, which one is recommended? First one is recommended. That means writing the three variables in the same line is recommended to use. So this is about how to declare a variable and how to initialize a variable. Basic concept. Now observe here, there is a concept of static initialization and dynamic initialization. So you have to observe that what is meant by static means. So see, observe this statement. If I write this statement and exit, and if I'm going to write this one in your Java program, this is the value is constant value here. This is constant, but that means what? The value will be always 30 here. So this will be decided at compile time only. That means the value of y will be decided at compile time, that is 30. But see this example once. I am going to take int a equal to 30 for suppose, and b equal to 20, and C I am going to write, I am not going to take any value here. So at compile time, we know that A equal to 10 and B equal to 20, we will understand, your compiler also will understand. But coming to C value, did I give any C value? No. If I write C equal to A plus B, this operation is going to be performed at runtime. So the value of C will be given at what time? Runtime, which can be said as dynamical initialization. Sorry, dynamical or dynamic initialization of variable initialization, because this the value of C is going to be initial at what time? At runtime, because the operation is going to be performed at runtime. So this is about the concept of variables, declaration and initialization we have discussed. Now very important concept, that is scope and lifetime. So scope, if you are going to get any question on these variables, they will ask you what is meant by a variable and explain about scope and lifetime of a variable. So I'm discussing about scope and lifetime of a variable. So what is meant by scope and what is meant by lifetime? First see here, from where to where. From where to where is nothing but scope. Where to where is nothing but what? Scope. Next, coming to lifetime, when it is going to be created and when it is going to be destroyed. This is nothing but what? Lifetime. Lifetime. So where to where is scope, and destroying, sorry, that is nothing. Lifetime is nothing but what? From where it is going to be, when it is going to be created and when it is going to be destroyed. So now observe here, just I will take a small example to demonstrate this. Uh, just I am not going to follow syntaxes, because for us now concept is important. Just I will take the, I want to show you the scope of the variable here. Just I am going to take directly public static void main here, public static void main, directly I am writing here main, and in brackets, as you know, that string array args will be there. Right now observe carefully here. Here I am going to take one value, that is int x equal to 20 I am going to take. Now observe carefully here, as you know that your main is going to start it from here and ends here, and your class is going to be started here and it's going to end here, for example. Now here, where x is created inside main, so that x can be accessed from this parenthesis to this parenthesis. That is nothing but the scope of this x is inside this block, inside this method. From where to where? From this bracket to this bracket. It is nothing but a scope. Now observe carefully. Next, I'm going to take one more thing here. I'm going to take, for suppose, if I am going to take here, if uh, 10 greater than 20, I am going to tell, or sorry, 10 less than 20, I am going to take. Now observe here. Here I am going to create one more variable, int k equal to 30. Now observe carefully where this variable is going to be created, inside this block. Inside this block. The meaning of this one is what? The scope of this k is from where to where? Only within this block. Outside of block, this is not going to be visible. So if I take a small example here, so just I will close this little bit downer. So let us close it here. Right. Now see, here I am going to take, I am using, for example, if I use x, there is no problem, because x can be accessed inside this block. If I use k here, k is created where? Inside if block, inside this if block. So it can be accessed, and the scope of this k is only within this block. If I try to use outside this block, we are going to get error, which is nothing but compile time error saying k is not defined because your main method outside of this if your main method don't know what is meant by k. So clearly it says it is going to give you what? Error. So I think you got the concept of scope. What is meant by lifetime? Lifetime is nothing but what? When it is going to be created and when it is going to be destroyed. So for this one, I'm going, this is scope example. So this is valid and this is what? Invalid. We cannot use it here. Now, I want to discuss about lifetime. So lifetime also will maybe looks like same as your a scope, but there is a little bit difference is there. Just by showing a small example, I will demonstrate that. Class, for example, as I am discussing about lifetime, I will write it as a life. Here, I am going to write public static void main. Please don't write any shortcuts. Don't use any shortcuts. So as it is a waste of time, I'm going to keep dots here, and I'm going to write string args here. So please don't write this type of dots or shortcuts in your examination. Now see, I'm going to create int x here and I'm not going to take any value here. Semicolon. Just I'm going to place what? Semicolon. So for observe now x equal to 0 something I'm going to x equal to initialization 0 and here I'm going to place x less than 3 and x plus plus. So now see here inside this I'm going to take int y equal to 10 for suppose int y equal to what? 10. And after this, I'm going to print y. So system dot out dot println. I am printing the value of what? Y. And after this, I want to change the value of y. That is y equal to 50 for suppose. And again, I am printing what? System dot out dot println y. Now observe carefully. This example is very, very important. Now see here, I'm not discussing about the scope now. I'm discussing about lifetime. So what is meant by lifetime, sir? Whenever variable is going to be created. So when this variable is going to be created, whenever we are entering into this method, your variable is going to be created. And what about this y? When it is going to be created, once if you are going to enter into this for loop, your y is going to be created. Now, whenever x is going to be destroyed, if the control comes out of the, if the control comes out of the which loop? Main loop. That is not loop, sorry. Out of the main method, we are going, this x is going to be destroyed. What about this y? If it comes out of the, observe now, if it comes out of this for loop, your y is going to be destroyed. That is what I am going to done here. For loop I have written here x equal to 0, x less than 3. So this is nothing but x plus plus. It is not 44. It is what? X plus plus. So now what happens here? First time, this is what? Y equal to 10. So first it prints what? Y. Y value as so initially it will print 10. Next after that I am making y as 50. Again I am printing what? Y. So it will print as what? 50. Now observe carefully. Now before going to continue next loop, that means so from here to here if I want to jump, I will come out of the for loop. Out of the for loop. So what happens? That y value will be destroyed now. Again, whenever you are entering into this for loop, once again for x equal to 1, again y value will be initialized with what? 10. Again the value is what? 10. Again I'm changing it to 50 and I'm going to print it 50. Again if I come out of this loop, your variable is going to be destroyed. And once again I'm coming inside this one. This variable is going to be created once again. And again I'm printing it. What happens? Again, it is going to be printed as 10. Again, I'm changing it and I'm going to print as 50. Don't think that as y value is changed here, once again y value will be 50 or 50 plus 10, 60 like that. So once if it is changed also, if we come out of this one, the variable is going to be destroyed. There is nothing but a lifetime. Now tell me what is the lifetime of this y? The lifetime of this y is until the completion of this for loop. So whenever it is going to when it is going to be created, once we are entering into a for loop, in this example, for loop, once if you are coming out of the for loop, that value is going to be removed. So this is the concept of uh, what is that? Lifetime and scope of a variable. Okay, right. So now let us discuss the concept of. So till now we have discussed what data types, and next one we have seen about identifiers. Next time we have seen about literals and so on. Now we have seen about variables also. Now I am talking about type conversion and casting. Very important concept and easy concept. So what is meant by type conversion and how many type conversions are there? Now talking about type conversion. So now see, in the type conversion is nothing but what? Converting from one type to another type. Converting from one type to another type. Next, how many type conversions are there? There are two types of type conversions are there. One is widening conversion. One is what? Widening conversion. Another one is narrowing conversion. So next one, this is implicit conversion, and next one we can consider it as explicit conversion. Okay, explicit conversion. So these are two types. Otherwise, we can consider the normal automatic type conversion, automatic type conversion. Next, coming to your second one, this can be considered as type casting. Very important, type casting. The concept will be very easy. First, I will explain about widening or implicit or automatic type conversion. What is meant by this? So here, before going to see this, already I have explained about your data types, data types and literals. So I will draw you a small diagram where it will be very easy to understand this concept. So now, as you know, the different data types are there. Byte is there. Next, I am going to it. Next highest one is what? Short. And next one is what? Int. Int data type is there. Next one, after this, long. Next, after this, we are having a float. Next one, we are having, after float, we are having what? Double. So please, what I can say, remember this diagram so that type conversion is completed. That means what? I can, if I am going to write, see, observe now, just I am going to write int x equal to, int x equal to. Now the concept is which values or which type of values here I have to write. Which type of values I have to write, then it will be valid. That is, see, observe now, what are the types that are present in front of int? That is written byte short char. That means what? Instead of this question mark, I can write either which type of same type. Next one, I can write char type. I can write short type. I can also write byte type. The meaning is what here? All these four types can be converted into type. All these four types can be converted into type. Am I converting this one separately or explicitly by writing any cast operator? No. This will be conversion will be done by your Java, or let us say will be done by compiler. Okay, conversion will be done by compiler. I am not going to convert anything here. Automatically conversion is going to be taken place. So next I will take one more example here, float. I will take float. So if I take float here, inside this float, which values can be taken? That is, long value I can take, int value I can take, char, short, byte. I can take any type of value here. Automatically, it will be converted to what? Float type. So please remember the diagram. So here, what can I say? Instead of telling conversion, I can also say it as a type promotion. That means what? Byte can be promoted to short and byte can be promoted to int. Byte can be so not this. This is not necessary. So byte can be promoted to int. Byte can be promoted to long. Byte can be promoted to float and also double. Coming to short, short can be promoted to int. Short can be promoted to long. Short can be promoted to float. Sir, what is this? What is this promotion? For example, a small hierarchy I am going to take. Constable is there. Constable, if I want to promote him, I will make him as what? Head constable, for example. I'm going to make him as what? A head constable. That is, I will write only HC. If I want to promote head constable, I'm going to send it as ASI. After that, if I want to promote him, I'll make him SI. So is it possible to promote from SI to ASI or ASI to head constable or head constable to constable? This promotion is not possible. What is meant by promotion? Constable to head constable or constable sometimes directly promoted to ASI or sometimes he can go promoted to SI. In the same way, byte can be promoted to all these types. Short can be promoted to all these types, but reverse is not possible. Reverse is not possible. That means what? If I am going to take here int, int y equal to, if I write any floating point number, by default it will be what? Int. Sorry, by default it will be what? Double. So here this is double value. Automatically, can I store this double value into this int? No. Already told reverse is not possible. So that this is not possible. This is what? Not possible. So what I have to do, sir? If it is not possible, if automatic promotion is not possible, what I have to do? So one more point I want to tell you why it is called as automatic type conversion, because I am not converting anything here. If I write 10 here, 10 is int. 10 can be converted to float. Am I converting it? No. Automatically it is going to be converted. First point. Next, coming to implicit. Am I converting explicitly by writing any conversion here? No. So that it is called as implicit. Why it is called as widening? Observe carefully. This is what int type. Okay, I will take a better example for that. For example, by removing this, I will tell you. By clearing this, just see. I am going to take one small example here. Double d equal to I am taking one integer, that is what? 30. So this is what? Int type. This is what? Int type. And this is what? Double type. Okay. The size of this one is what? 8 bytes. And the size of this one is what? 4 bytes. Int is 4 bytes. So just I will draw a small diagram for this one. So see, int is 4 bytes. This is int. So I am storing it in where? Double. I am storing it where? Double, which is 8 bytes. So widening, that means what? Smaller to bigger. It is called as what? Widening. Now I'm talking about what? Narrowing conversion. Next case. This is completed about your automatic type conversion or implicit conversion, or we can say it as a what? We can say it is also as implicit conversion. Okay. Implicit, widening, or automatic type conversion. Now observe carefully second case, type casting or narrowing conversion or explicit conversion. First, why it is called as narrowing, I will tell you. Larger type, double I am taking. If I want to store double, that means bigger value in shorter type, that is what? This is double, 8 bytes. And if I want to store it in int is how many bytes? 4 bytes. So bigger to smaller, it is nothing but what? The way is going to be narrowed. That means first it is widened, next it is going to be narrowing. So that I'm going to take the call this conversion as what? Narrowing type conversion. So what is this, sir? How to perform this? So now see, just I will show you with one example. That is, I'm going to take a int type. So int x equal to, I am taking some value 25.75. So if you observe this floating point number, you can say that this is double, which is 8 bytes. This is int type, which is 4 bytes. It is not possible according to our previous one. So explicitly what I have to do? Explicitly, I have to use a type casting. What I have to use? Type casting. So I have to write the cast operator. So which type I want to convert? I want to convert into int type. So int I am going to write what? 25.75. So now observe here, this is double, which is 8 bytes. This is int, which is 4 bytes. I am going to use, this can be considered as cast operator. Which operator? Cast operator. And I am using, it is not going to be done automatically. I am going to use what? Operator explicitly. In before case, what I have, did I use any operator in this case? No. Int is automatically converted to double, but coming to here, double is not going to be converted to x int by default. I have to use what? Explicitly, I am going to use some cast operator. So this is called as what? Explicit. Explicit conversion. This one is what? Narrowing. Why it is called as narrowing, I have explained here. Why it is called as explicit, I have explained here. Now, why it is called as type casting? Because I have used what? Operator called as cast. This is the, if you write brackets and inside the brackets, if you write any data type, we can call it as what? Cast operator. As we are using cast operator, I can call this one as what? Type casting. So finally, there are two I am going to summarize the concept. So here there are two types of castings are there. One is one is type, we can say widening conversion and narrowing conversion. Widening is also called as what? Implicit, and also called as automatic type conversion. Coming to your narrowing is also called as what? Narrowing is nothing but explicit and also called as a type casting. Okay. So in this case only, in this example only, I have explained about the concept of automatic promotion also. That means what? Byte can be, I have drawn one diagram. Byte can be promoted to what? Short. Short can be promoted to what? Int. I have shown this example. Int can be promoted to what? Long. Long can be promoted to float. Float can be promoted to double. Reverse is not possible. Am I promoting it? By default, your compiler is going to promote this. So that I can say this one as what? Automatic type promotion. This diagram is very important for automatic type promotion. Sir, what is this? Let us take a small example for this type promotion. So I'm going to take byte value here. Otherwise, better I will take a easy example to demonstrate this. I'm going to take two int values. Int a equal to 10, b equal to 20 I have taken. Okay. Now I am going to take one double value here. One double value. So c equal to, I am going to take, for example, 2.5. 2.5. Now just I am going to write what? I want to perform one operation, that is 10 into, sorry, a into c. That is nothing but water. A value is what? A value is 10. This value is 10 and C value is water 2.5. Now if I am going to perform this, I am going to get value as water 25.0. I am going to get what? 25.0, not 25, 25.0, because this is which type? The type of this one is what? Int. And the type of this one is what? Double. Among these two, which one is larger? Among these two, which one is larger? Double is larger. So that the answer is also will be in double. So that we have to store this answer in double. For example, double D. That's it. This is about the concept of automatic type promotion in your expressions. Okay. So remember one point that whenever you are going to perform type promotion, whatever in an expression, whatever the maximum value in that expression gives you what that will be output of that expression will be same. If you see this example, A is int type, C is double type. Among these two, which one is having highest type? C type. That is what C. That is nothing but double. So that this expression will give the results in what? Double. So we have to store this value inside a double only. Okay. So this is about what? Type conversion and type casting, and also we have seen about type promotion. Next, if you next after this basic concept will be what we have seen about variables, and also we have seen about this type promotions and so on. Now let us talk about the concept of types of variables. So before going to complete the concept of uh, variables, we should know about the classes. So I will not discuss about that. Now let us talk about operators. So it is also one of the important questions. So as you know that how many operators are there? So what is meant by operator? Let us see first. So operator is nothing but if you want to perform any operation, we require the concept of operators. So operators is also one of the important for performing the operation. So operation is what? Operation is nothing but combination of operators and operands. So again, I'm repeating. Operation is nothing but here I will start the concept of operators. Now see, operators. Sorry, operators. I'm talking about operators. So when it is going to be used, if you want to perform any operation, that is C equal to, I want to write A plus B. I'm going to consider as this is one operation. This is what? One operation. So if I want to perform this operation, what I require, if you observe clearly, you can see what? C, B, sorry, A and B. These are what? Operands. These are called as what? Operands. And equal to and plus is called as what? Operators. So to perform any operation, we require data and operators or operands and operators. Okay. So let us see what are the different types of operators available in Java. So if you see this one, generally our basic operators in our Java are first one is arithmetic operators. Very basic one, arithmetic operators. So basic one we are going to see about arithmetic operators. And if you see taught entire thing, first one is arithmetic operators we are going to discuss. After that we are going to see about relational. After that we will see about bitwise, and after bitwise we are going to see logical operators. So these are the four different important types of operators. If there are any other important, we will take it as other operators. Okay. So first let us see about arithmetic operators. Directly I am going to write it here and I will explain. First one plus, which gives you addition of two numbers. Second one is minus, which is going to perform subtraction of two numbers. There is nothing but it will give you difference of two numbers. Next we are going to have an operator called as star. Star indicates multiplication of two numbers. And next one is division symbol. So here if you observe these, it will be clear that, so 1 minute. Right. It will be clear that for you, it will be clear that these are the four basic arithmetic operators. So first one is addition, second one is subtraction, third one is multiplication, and fourth one is division. Now, one more important operator is there, that is nothing but modulo. So just I will take a small example here. So I am going to take A equal to 10 plus 20. You know it results what? It's going to perform addition. So answer will be what? 30. And next coming to B equal to 20 minus 10 for suppose. So I'm going to get answer as what? 10. It is going to perform subtraction. C equal to 5 into 2, for example. So I'm going to get answer as what? Multiplication of 5 and 2, which leads to 10. And now see D equal to, as you know, it is going to perform, slash is going to be perform, sorry, divide by symbol is going to, forward slash is going to be performed as what? Division. So we are going to get what? Quotient, not remainder. We are going to get what? A quotient we are going to get here. Now see next one, modulus operator. So this is called as modulus operator, or we can also say it, okay, you can say it as modulus operator. Let us see what it is going to give. 10 modulo, 10 modulo 2. What is the remainder of this one? This will give you what? A remainder. Remainder means what? If I perform division operation for 10 and 2, I am going to get remainder as what? 0. One more example I am taking. If I am going to divide 10, for example, 10 modulo 3. If I divide 10 with 3, what is the remainder I am going to get? 3 3s are 9 and remainder will be what? 1. So modulus is nothing but remainder. Division operator is nothing but what? Quotient. As you know, all these we can also consider. We can also sometimes we can consider this plus plus and increment operator and decrement operator into your arithmetic operators. There is no problem. So now see, it will be somewhat uh, confusion when goes to increment and decrement operators. So now listen carefully to this. Easy if you understand. Observe now. Just I will take one value x equal to 10. 1 minute. Okay. X equal to 10 I am going to take here. Now I want to perform y equal to x plus plus. So before going to this, I want to tell you that so for both plus plus, that is increment and decrement, we are having pre-increment and pre-decrement, post-increment and post-decrement. So just I will explain about pre-increment and post-increment. Same concept will be applicable for your pre-decrement and post-decrement also. Observe carefully now. Now, as first statement executes, the x value will be 10. Now, listen carefully. X value will be 10. Now, coming to this one. So, what is this one? Post increment. That means post is nothing but what? After the variable, if I write plus plus, it is going to be considered as post increment. So, post increment means what? After performing a task, increment my value. What is the operation here we are having? Equal to. That means what? First, I have to give my x value to y. That means now what happens here? The x value is going to be given to y. What is the x value? 10. So 10 will be given to y, and after giving that value, your x is going to be incremented. So that means what? X value will be changed to 11. In this case, what is x? 11, and what is y? 10. Same example I am going to take with pre-increment. Pre-increment, observe. So y equal to plus plus x. This is called as what? Pre-increment. Pre means what? Before going to perform any operation, we have to increment. Post increment is what? After performing an operation, we have to perform increment. So now observe. So initially x equal to 10 I am going to take, and later I am going to take y equal to, now y I have to take. So x value is what? 10. Now y, what I have to do here? I have to increment this and I have to store it in y. So plus plus x. First I have to increment what? X value. So x value will be what? 11. And next what I have to do? I have to store it in y. So now see the values of these ones. Here if you see x value, it is 11. It is y value is what? 10. Y value is what? 10. But coming to here, x value is 11 and y value is 11. So this is about pre-increment and post-increment. Okay. So if you have any doubt, you can just send me a message. Okay. Right. So also, say, coming to this, so we have seen these operators. That is what, just I will erase this. So erase all these examples. Now observe. Now see. Now again, few more. We can consider them as a arithmetic operators, which includes equal operator also. As we are having plus minus and this one, just I will write plus equal to and minus equal to, and next star equal to, and next I can make it as slash equal to, and so on. That means what? So on is nothing but we are having again modulus is there. So I can write modulus equal to also. So these are what? We can say these all are as. So these are as what? For example, first one, plus equal to is nothing but addition assignment. Meaning is what? For example, I am having x value, I am going to write x equal to, I am going to write x plus equal to 10 for suppose. X plus equal to 10. What is the meaning of this? How it is going to be executed? This is nothing but x equal to x plus 10. The answer will be 20 only. What is this? Answer will be 20. If I write this one, answer will be what? 20. So this is same as this expression. So that instead of writing x equal to x plus 10, directly I am writing what? X plus equal to 10. So in the same way for minus equal to, star equal to, divide by equal to, and modulus equal to. Right. Now, next operators. So this is what we have discussed till now is nothing but what? Arithmetic operators. Next one. So whatever the examples I have written here, please take one class and take one main method and write down all these expressions. Then you will get the one program will be completed for this arithmetic operators. Now let us talk about bitwise operators, which are very important. So okay, let us see first relational. As we have written here, relational. Let us talk about relational operators. So in the name it says what? It is going to show me some relation. Relation is what? Let us consider. If I am talking about you and your brother or you and your sister, for example, what is the difference between you and your sister? She is greater than you. That is, age is higher than you, or age is less than you. Or for example, he is more. Uh, she is having more marks than you. She is having less marks than you. That means relation always tells you either both are equal, either both are equal, or both are not equal, or whether one is greater, otherwise less than, otherwise less than, greater than or equal to, otherwise less than or equal to. That means what? Always relational operator tells you what? Whether both are equal. That means what? Here, all these are comes under generally where we are going to use these relational operators means these are also called as conditional operators. Where these are used? Whenever we are using a condition, you can see all these types of, you can see these types of operators in conditional conditions. Let us take a small example for this. I'm going to take int a equal to 10, comma b equal to 20 for suppose. So here what I'm going to do, just I want to tell which one is larger. So just I'm going to write if statement here. If a is less than b, what I have to print? System dot out dot println just a, that is a is greater. If it is sorry, a is sorry, here I have to print what? B is greater. Next, else case, system dot out dot println, what I have to print? A. So now observe carefully what I am going to do here. So observe this one. This is a condition, and in this condition, I am going to use an operator. It is which operator? Less than. So what it results? A less than B. Is A less than B here? Is 10 less than 20? Yes. If 10 less than 20, what I can say? B is greater. Okay, that means what? All these conditional or relational operator returns you one type called as a boolean. Either it returns what? True, or it returns false. If it is true, in this case, it will execute if. If it is false, if this condition is false, I am going to execute else. So the meaning is what here? Here, I have shown you relational operators, or we can call them as conditional operators. So generally, these operators are used in the conditions as we have seen in our example. Always your conditional or relational operators is going to return you a Boolean operators, which of sorry Boolean type. So this is about your relational, what we can say, relational operators. Next, coming to your bitwise, very important, and it will be very useful in your programming also. Right, first one. So bitwise. So for everything, I will explain an example. So first one is what? Bitwise. So it is symbol is what? Not symbol. Next one is unsymbol. Next one is or. Sorry, or symbol. It is going to have only one straight line symbol. Next, we can say this one as cap symbol, which gives you XOR. And next, we are having shift right and shift left, and one more symbol, that is what? Three right side symbols we have to give, which indicates shift right zero fill. This can be called as what? Shift right zero fill, or we can call this one as unsigned shift. Unsigned shift right. Again, I'm repeating. This is called as what? Unsigned shift right, or we can consider it as a unsigned, shift right with fill with zero. Okay. So now just I will take a small examples for everything here. So first I'm going to take not. Not means what? As you know that here the name says what? Name itself saying what? It is nothing but a bitwise operator. That means what? Whatever the values I am going to take, convert them into bits and make them into, sorry, and perform these operators. That is, see now, just I am going to take one example here. I am going to take a equal to 10. Small example I am taking. Just I want to perform negation of, sorry, not this, not a. What is that? Not a. What happens here? Not a means, so zeros will be converted to ones and one will be converted to zero. So just I will take four values. If I take it as a int, observe carefully. If I take it as int, you have to take 32 bits. But as it is an example, just I am going to take 4 bits. So it is a 10. The value for binary value for 10 is what? This one. Now, if I want to perform negation, so a, this one is a, and if we want to perform negation of A, what I have to do, or not A, just I have to convert the bits here, 0, 1, and this is 0, this is 1. So answer we are going to get is what? 5. So not is nothing but converting 0 to 1, or if 1 is present, we are going to change it as 0. This is what? Not operation, not bitwise operation. Next one, AND operation. So before going to perform or show this example, just I want to tell you what is AND, what is OR, what is XOR by writing a small table. So just I am going to write here A and B, and next let us take A or B, and next one A XOR B. So it will be easy for you. So here I am going to take two values, 0 0, 0 1, and next 1 0 and 1 1. And B, and is going to have what? And is going to give output as 1 only when two are ones. So when A and B are ones, output will be 1. In this case, these two are 1. So output will be 1. So here, are these two are ones? No. So 0. Are these two are ones? No. 0. Are these two are ones? No. 0. That means AND operation is nothing but what? Whenever two bits are ones, then only output will be 1. In other cases, output will be 0. Coming to OR case, OR, that means what? Here we are going to give both are ones only, we are going to answer as ones. OR case, at least one one. If at least one is present, then automatically answer will be 1. So here is there at least one? No, there is no 1 here in first case. So that answer will be 0. Next, in this case, in this 0 1, here 1 is there. So answer is 1. In this case, at least one is there. So answer is 1. In this case, at least one is there. Answer is 1. Completed. Now finally, XOR. So XOR always gives you when two different values are there, answer will be 1. If two same values are there, answer will be 0. That means, see here 0 0 is there. So 0 XOR 0, two same symbols 0. And 1 XOR 1, two same symbols 0. Now 0 1, 0 XOR 1, two different symbols. So answer is 1. 1 XOR 0, two different symbols. Answer is 1. So this is in this way, these three operators are going to be performed. So if I will take a small example here, so I'm taking two values, observe carefully, I will perform all the operations for these. First I will perform AND, next I will perform OR, next I will perform XOR. So I'm going to take A value as 10 and B value as 5. For suppose I'm taking small values here. So A value is 10. So 1 0, 1 0, and then 5 value is 0 1 0 1. So now see. So if I'm going to perform AND operation, these two are not 1 0, these two are not 1 0, these two are not 1 0, these two are not 1 0. So answer is what in this case? 0. And next coming to OR operation, values are what? 1 0, 1 0, 0 1, 0 1. In this case, what? OR is nothing but what? At least 1 1. If 1 1 is there, automatically we are going to get output as 1. So that here at least one is there, 1. Here at least one. Here also same, here also same. So answer is what here? We are going to get 15. Next here, third case, XOR case. Here I am going to take 1 0 1 0 0 1 0 1. XOR means what? If two different symbols are there, we are going to get answer as 1. So here it is what? 0, it is 1. So different. Here also different. Here also different. Here also different. In this case also, we are going to get same answer as 15. So this is about your AND operation. Next one, OR operation, and next one is what? XOR operation. Now I want to talk about very important thing, that is left shift, and I will tell you a shortcuts how to deal directly without performing any right shift or left shift operations. Now observe carefully. Again, I'm repeating. I'm talking about bitwise operators. Meaning is what? Bitwise operators is nothing but we have to perform these operators on bits. Bits means what? Zeros and ones. Okay. First, I will talk about this is right shift. Okay. So this is right shift. I will talk about right shift here. Just I will take a small value. I am going to take a equal to 32. Let us consider a is int. This is what? Int. So as you know that int is going to have how many bits? Total 32 bits. Anyway, I'm not going to tell all those things. Just I want to write the value of 32 here. So as we know that the value of 32, generally it is going to take what? 1, 0, 0, 0. This is 8, this is 16, and this is 32. Now observe what I want to do this 32. I want to shift right. That is this one. Shift right how many times? 2 times. So I want to shift the value 32. How many times? 2 times. So what happens? Let us see. This is whether 32 or not. This is 1. This is 2. This is 4. This is 8. This is 16. This is 32. So the value of 32 is this one, right? Correct. Now I want to shift that 32 how many times? Right side 2 times. That is, so just I will write it here. Now see, these two values will go out, and this value will be placed in this position. Next this value here. Next this value here, and one will be here. That means what? Finally, we are going to get in this way. And here two locations are left with. So what we have to place? What we have to place? Zeros. What we have to place? Zeros. Generally, if it is I have not written all the values, but if I written all the values, leftmost bit, this indicates what? Negative. But here, 32 is nothing but what? All zeros will be there. Remaining all zeros will be 32 bits I have to take. So first bit is what? 0. So that for this one also, I have to place include what? Zeros only. If it is 1, I have to place 1 there. Okay. Right. Anyway. So answer is what? Main thing answer we have to see. Answer is 1000, which indicates 8. Which indicates what? 8. Sir, I think there is a relationship between 32 and 8, sir. What we have observed here? See here. I have taken 32. For one shift, what happens? For one shift, it is going to be divided by 2. So answer is 16. But here, how many shifts I have done? 2 shifts. For one shift, the right shift 32. For 2 shifts, again 16 by 2. So answer is what? 8. For every right shift, it is going to perform what? Divided by 2. For every left shift, okay, this is about right shift. Here I have performed 2 right shifts. So that divide by 2, divide by 2. Now I want to talk about same example, but with left shift. This is also very easy. So what is the difference between right and left? So right is opposite to left. In the same way, while you are performing the operation shift right, what you have done? You have divided. Now I am going to take a value as 32. So this is 32 value here I have written. Now I want to perform left shift. That means what? 1 and the 0 comes here. And what happens? All four is 1, 2, 3, 4. Here what happens? These two also will be 0. Now if I shift 2 times, so A left shift 2. Now what happens here? All the, two values are shifted left side. Now what happens? I have taken the value as 32 and this value is nothing but 128. This value is nothing but what? 128. You can observe. Already you know that 8421 notation. So 1, 2, 4, 8. This is 16, 32 and 64 and this is 128. So as this is only 1 here, so the value will be considered as what? 128. So now see how it has been done. So shift right, what I have said, divided by. So right shift means what? Divided by. Left shift means what? Opposite to divide. It is nothing but multiplication. So if I am going to perform one left shift by I have to multiply it by 2. If I am going to do two shifts, two left shifts, I have to multiply it by 2 times 2. That is what 32 into 2 and 2. So 32 2s are 64. Again into 2 is nothing but what? 128. Okay. So this is about what? Concept of this is about concept of what? Left shift. Next, coming to important one, that is nothing but shift. This is what shift right fill with zero. It is also called as what? Unsigned shift right. So please observe carefully here. Just I will take a small value as I know this example. Directly I am writing here. So A equal to -1 and I want to perform A equal to A uh, shift right fill with zero. How many times? 24 times. So easily I will explain. Because if I take -1, I know the -1 value, which is nothing but 32. I have to write 32 ones here. 1, 2, 3, 4, 8 here. Next 1, 2, 3, 4, 5, 6, 7, 8. In the same way, total 32 bits I have to take here as it is integer. Okay. Right. Now listen carefully here. Just if I shift 32 bits, that means what? All these bits are going out. So next what happens here? This value is going to be given here. 1, 1, 1, 1, 1, 1, 1, 1. Now the question is, here which values has to be placed? All these has to be zeros. All these has to be what? Zeros. Sir, while you are explaining the concept of, excuse, okay. While you are explaining the concept of right shift also, you have discussed the same thing, no, sir? Yes. But the difference is, same example, once again, I will explain here also with right shift. A equal to -1. -1 value is what? All ones I said. Same concept, all ones. But after shifting right shift, what has to be placed? 1 minute. It will be clear if I write clearly. Just I will take -1 value. 1, 1, 1, 1. I will take only 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. All remaining all are also ones. Now if I shift 24 times, all these 24 bits will go out and these 8 bits are going to be given here. And what about 24 locations here? In these 24 locations, what I have to place? Generally, this last bit is going to be placed here. Okay. This is about right shift. But what about left shift? If you are going to do, sorry, not left shift. What about right shift fill with zero or unsigned right shift? We are going to keep what? All zeros. I don't know whether it is 1 or it is 0. I'm not going to bother about that. Instead of going to place 1 or 0, directly I'm going to place for zeros only. It may be 1 or it may be 0. I'm not going to bother about that. Only zeros I'm going to place here. But coming to this case, if it is 1, last bit is 1, I'm going to place what? All ones. If let us consider after shifting, I'm going to have last value as 0. Then remaining values will be what? Zeros in your right shift. But coming to this case, we are going to take what? Uh, it may be 1, leftmost bit may be 1 or 0. I am not going to bother about that. I am going to place zeros. So that the name of that one is what? Right shift fill with 0. Or we can say it as what? Unsigned, unsigned right shift. So again, there are two more operators are there. Let us complete. Next one, logical operators, which is very easy. So both, if you consider logical operators and bitwise operators, both looks like similar, but they are different. So bitwise means what? We have to apply on bits. We have to apply on bits. But coming to your logical operators, coming to your logical operators, here we are going to be applied on true or false. What is that? True or false. So operations will be same, but the symbols are going to be changed here. If we apply AND operator between true and false, this AND operator is called as what? Logical operator or Boolean logical operator. If you apply this OR operator in between between true or false, we can say it as what? Logical. In the same way, XOR. This is nothing but what? Short circuit OR. This is nothing but short circuit AND. And as we have seen not in our bitwise, this is also called as logical not. This is not called as what? Logical not. This is called as normal not, bitwise not. Okay, right. So now observe carefully here, where everything is easy. So as we have shown about these cases, zeros and ones I have taken, but here what I have to take? True and false. Same. Whenever there are two truths, then only for and answer will be true. Again, I'm repeating. If two ones are there, if two ones, one and one, sorry, here in the case of bitwise, we have to take one and one. But here, if it is true and true only, we are going to get answer as what? True. In all cases, it is false. Now here, true. When we will get true, at least one true is there. If at least one true, I am going to get answer as what? True. Next, coming to XR, if both are different, different, if both are true, both values are true. Sorry, if both values are different, one is true and one is false, then answer is what? A true. Next, otherwise it is false. Now coming to this short circuit, and then short circuit are here. What happens in these two cases? I don't want to check two conditions. For example, see here, if 10, observe carefully, if 10 greater than 20, here I'm going to and 20 less than 30. Observe carefully here. What I said here, this is short circuit and that means what? So this is which operates all short circuit and so this results what? Is 10 greater than 20? No, it is false. If it is false, see, in AND operation, if at least one is false, automatically entire condition is what? False only. So no need of checking this. Again, I'm repeating. In AND operation, if at least one is false, no need of checking second one. So short circuit does the same. But in the place of this short circuit, if I'm going to the single AND, we have to perform this one, we have to perform this one. So that if you are performing short circuit, the performance is going to be increased. Short circuit. Okay. In the same way, if I am talking about, for example, here I am having 70, sorry, 70 greater than 20 or 20 less than 30. Observe now here. So is this case is true or not? Yes. If it is true, what is the need of checking this? No need of checking this. Reason is what? In your OR case, what happens? At least if one is true, automatically another one, it may be true or it may be false. Answer will be what? True. So these are short circuit OR and this is what? Short circuit AND. In these two cases, so if it is in AND case, in short circuit AND case, first one is false, it will not check. Second one. In this case, for example, if it is true, compulsory in short circuit also we have to check for second condition because based on the one condition I cannot decide the answer in AND. Next coming to this one, if it is false, for example, if first condition is false, we cannot decide the answer. So compulsory we have to check for second condition also in which one? Short circuit OR case. As you know, this is nothing but what? If I'm going to give true, not true is nothing but what? False. Not false is nothing but what? True. So this is about different types of operators in our Java. Lastly, we are having one important operator that is called as what? Ternary operator. Which operator? Ternary operator or conditional operator. How it is going to be worked? So here, let us take a small example for this. Just how it looks like. First one is condition will be there. Condition and question mark will be there. Here statement 1 colon statement 2. Directly I am explaining here. Whenever this condition is true, whenever this condition is true, automatically it will go to statement 1 when this is true. Okay. Next, whenever this is false, it will go to statement 2 whenever it is false. So just I will take a small example for this. So int x equal to I am going to take if 70 greater than 60. If this condition is true, first statement has to be selected. Just I am going to take it as what? 70. Next colon, I am going to take second value as 60. That means In this only single statement or expression, I am going to find out the greatest of two numbers. So observe now, is this condition is true or false? Yes, it is true. So that which value is going to be executed? First state. That means this value is going to be stored here. So 70 because what? This condition is true. Okay. This is ternary operator. And finally, as you know that there is an assignment operator. So we can write, as you know, assignment operator is nothing but what? Equal to. So for example, I'm going to take equal to 20. Now, 20 is going to be assigned to A. That means what? This is so that it is called as what? Assignment operator. In the same way, if we want to take multiple assignments for a, say, sorry, if multiple variables are having same, I can write like this. Okay. Int A equal to B equal to C equal to 30. Okay. So this is about the concept of operators. So in this session, we have discussed about mainly from basic Java program we have discussed first. After discussing the basic Java program, we have seen about data types, next variables. After variables, we have seen the scope and lifetime of a variable. So after that, we have seen literals and also identifiers. Next, we have seen about typecasting, type conversion and typecasting. And finally, we have seen the concept of operators. So, so remaining concepts, let us continue in next session. Okay. Thank you.